Hello, my dear students. How are you all? My dear class, today we will cover a very important and very easy and commonly used unit for the measurement of volume. Now, we will begin from the definition of volume. As volume is how much space is occupied by any object. So, it is defined as the volume of an object is a measure of the amount of space occupied by that object. As you see, the volume is the measurement of three-dimensional length. So, the unit of volume is again raised to the power 3. An SI system selected cubic meter as the international unit for measuring volume. Now we see there are many units which are interconverted with the power of 10, as this is based on metric system. So you must know that what are the smaller units and what are the larger units and by what factor they are related. Now you see very small units are millimeter cubes, centimeter cubes, then comes a bigger unit meter cube and kilometer cube. Now one thing you can notice that this is a measurement of 3 lengths. That is why all the time the unit of length is raised to the power 3. And you also have to relate the factor through which they are connected. You see, if you know the smaller value, you can simply click your calculator buttons to know the value of a larger or much smaller unit. So you will just remember that the most commonly used unit for measuring volume is centimeter cube. So there are two units, like 1 meter cube is equals to 1000 decimeter cube. Now this 1000 means 10 raised to the power 3 times. So you have to remember the relationship. And further, you can also say that 1 decimeter cube is equals to 1000 cm cube. Again, they are related to 10 raised to the power 3 factor. So these relations will help you in solving calculations and numericals in your exam also. So you just remember them. The next is, how do we measure volume of liquids? There are different instruments especially designed to measure the volume of the liquids. Remember that we are doing the measurement of volume with liquids, and liquid is the phase in which there is no specific shape, but the volumes are exactly the measurement of the amount of mass. So we need to be very accurate in taking these measurements. So there are different shape and different sizes. The first one is this one. Yes, this is a measuring cylinder because it's of cylindrical shape. So they are of different sizes or different capacities. Sometimes we use 50 ml or 50 cm cube measuring cylinder. Sometimes we use 100, sometimes we use 250 or 1000. So it depends how much volume we are measuring. Then you also have observed that the syringes which are used to inject a definite amount of liquid medicine. Now this one is the burette. Yes, the spelling is B-U-R-E-T-T-E. So burette is a very special glass made instrument which has a running cork. This one is a running cork, or you can also say it's a tap to run the liquid through this nozzle, and it is also marked with the scale lines on it. They are of different sizes, and this one is used for measuring any amount of liquid. Then comes the pipette or pipette. Its spelling is P-I-P-E-T-T-E. So the pipettes are of different sizes having different capacities. Normally the pipette which is used in lab is 10 cm cube or 10 ml. Okay, and there's a mark on the pipette. So what we do, we suck the liquid through some sucker bulb, then the liquid rises and it fills up the pipette until it reaches this line, and when it reaches the line we stop sucking, and this is how we can measure a definite amount of fixed amount of liquid through it. Then comes these volumetric flasks. When we need to make solutions in the lab, then we need to mix up the amount of chemical, calculated amount of chemical or substance in the calculated or measured amount of solvent. That is why we used these flasks. Another time I tell you that these flasks are marked with lines on it. So they are of different capacities, sometimes 25 cm cube, 50 cm cube, 500 cm cube, or maybe 1000 cm cube. So these volumetric flasks are often used in making solutions of known concentration. You will study about this later on. Okay, now I tell you something very important about the burettes. The burettes, you will be using them, or the pipettes or the measuring cylinder. What's so special about them? Whenever you are doing some experiment in the lab and you are asked to know or measure or record the reading, then you will be in trouble. Now I tell you how you will be at the safer side, how you will retake the reading of the liquid. Whenever these glass vessels have some liquid in them, and the liquid will make a curved line like this, sometime like this, or sometimes like this, or like this. As I told you about how you measure the thermometer, in the thermometer you get this kind of curved line, and in base of alcohol thermometer you get this kind of light. So this curved surface of liquid is called as meniscus, and this meniscus is the reading of the volume. And there are two kinds of meniscus. One like this, such as water-based aqueous solutions or alcohol, they make the lower meniscus. And with non-wetting liquids such as mercury, we get this upward meniscus. So we see where to keep the eye while taking the reading. It should be exactly on the level of the liquid, as this is shown in the diagram also, that you should put your eye, you should keep your eye just beside the level, just at the level of the meniscus to get the accurate reading. So this is what you are avoiding, any kind of errors or the parallax error or the error of the observation. So this is how, this is the meniscus. If you read the reading, this is 11 and this is 12, and there are 10 divisions in between. So every division is representing addition of 0.1. So this is the lower line, lower meniscus, and it's touching this line. So this is 11.1 and 11.2. So this reading is 11.2, right? Similarly here, the lower meniscus is touching 28. So it is exactly 28 cm cube, right? And just remember that in case of lower meniscus, you read the lower mark, and in case of non-wetting liquids or upward meniscus, you read the upward side. Okay, now that was all about measuring liquids. Now if you are doing some experiment and one of the product is gas, then you need to measure that gas using this specially designed gas syringe. This one seems like the injection syringe. It works on the same principle, that it is made up of two glass barrels. The bigger one, this barrel is marked with lines on it, that's scale. Okay, and the inside is attached a plunger. So as some reaction goes on and some gas produces, the gas is connected or inserted to enter this gas syringe, and the gas will push the plunger out, and this is how you can take the volume of the gas produced during this reaction. So how you can do it? Again, see, the reaction is going on here and the reaction is producing gas. The gas comes out, enters the syringe, it pushes the plunger out on which the lines are marked. So this is the line, and this much is the volume of the gas which is produced during this chemical reaction. It's very easy for you now. Now the problem is not to measure the gas. There is another area of performing chemical experiments, that how we can collect gases, because gases are of different physical properties. So the two important properties which are considered and very keenly observed here is that what is the solubility of the gas in water. So there are different types of gases. Some gases are very readily soluble in gases, and some of them are sparingly or very less soluble, and some of them are totally insoluble in water. So the method of collection will be different. Then what is the density of the gas? Now here we need the standard of the density of the air, and this is calculated that 1 mole of the air will be having 30 AMU. Now this is the standard for you. You will just see what is the molar mass of the gas, and you will compare that result with this 30. If the molar mass is lesser than 30, means the gas is lesser denser than air. Let's have some examples. Suppose if you are doing some experiment in which hydrogen is produced. Now 1 mole of hydrogen has 2 atoms of hydrogen in it, and 1 atom of hydrogen is have 1 AMU. So it's simply 2 gram or 2 AMU, right? So this 2 is much lesser than this 30. So you can say that hydrogen is less denser than air. But when you see carbon dioxide has 12 gram carbon in it and 2 times of oxygen. So 12 is the AMU for carbon. You can see it from the periodic table, and oxygen has got 16 AMU. You can again use your periodic table, or you can ask this question on the internet. So it will give you 44 AMU. Now this 44 is greater than 30. That's why carbon dioxide is denser than air. Now you will remember that there are two important physical properties. One, the solubility in water, the other is the density. And there are 3 methods available. First method is displacement of water. This method is, this is what? The gas is coming from this delivery tube and is passing through this liquid phase. So it is just bubbling up and collected in the gas jar in the space provided. So this is what the method is called as displacement of water. The gas is displacing water to remove other impurities, and this is the method which is performed for the gases which are insoluble or very slightly soluble, because they can pass through the water medium without being consumed. So which gases are collected by this method? Carbon dioxide, hydrogen and oxygen. So carbon dioxide, hydrogen and oxygen are the gases which are insoluble and slightly soluble in water. That's why they are collected in the chemical experiments using displacement of water method. The next method is downward delivery. So the gas is coming through this delivery tube and coming down. That's why it's called as downward. So what is the suitable gas which can be collected through this method? Is the gas is soluble in water. That's why we are collecting it without any water medium and should be denser. So these two conditions, the gas which is soluble in water, it cannot be collected by this way, and it is denser. That's why it is collected downward. And what are those gases? Chlorine and hydrogen chloride. So just remember that chlorine and hydrogen chloride gas can be collected by downward delivery. Now you must have understood this method, why we are collecting it upward. The third method is upward delivery. Gas is coming and collected upward and is filling up the jar, as it is soluble in water and less denser than air. That's why it is collected through rising. So ammonia is the gas which is collected this way. So this is not just to memorize. Now you have to apply these small facts to write the answer, to give the logic of that question. Now this is a summary of all the gases and by means of their solubility and density. You have to keep a strict eye on both of the properties, because if I talk of ammonia, ammonia is extremely soluble and lesser denser. That's why its method will be upward delivery. So I will advise you to write the method of the delivery, method of collection of these gases. As ammonia, you see the two properties. It's extremely soluble in water. It cannot be collected through displacement method. And this is less denser, so it will be collected by upward delivery. Okay. The next is carbon dioxide. Carbon dioxide is slightly soluble in water and is denser. So that is why we can collect it through displacement of water. Yes. If I write H2O, will you get it? Very good. You are doing chemistry and you must be very, very familiar with this shorthand writing. And in case of chlorine, chlorine is very soluble in water. So, and is denser as well. So it will be collected by downward delivery. Okay. The next is hydrogen, not soluble, less denser. Very obvious that it will be collected by displacement of water. No, I will write this symbol. Right. And in case of oxygen, again, the displacement of water method. And in case of sulfur dioxide, the problem with sulfur dioxide is very soluble in water and is denser. So it can be collected by downward delivery. Okay. Now we proceed for the last section. Now another time, if we are supposed to dry a gas, means we need to remove the water vapors from the gas coming out through some aqueous medium after reaction. So drying a gas means to remove water, and to remove water we need some drying agent, right? So there are commonly used drying agents are concentrated sulfuric acids, that H2SO4, and if I put C means that's concentrated, that's very strong. The next is quicklime, that's CaO, calcium oxide. Then the third one is fused calcium chloride, CaCl2. Now again, how we use and when we use concentrated sulfuric acid. Concentrated sulfuric acid is used to dry most gases including chlorine and hydrogen chloride. And you have to remember that you can dry any gas using concentrated sulfuric acid which should be inert, which should not be reacting with H2SO4. As in case of ammonia, ammonia readily reacts with H2SO4. That's why drying ammonia through H2SO4 is not a good decision. Next, we can also use drying agents as quicklime. The gas is passed through calcium oxide to remove it from water, and ammonia is collected by upward passing. And again, moist hydrogen can be dried through calcium chloride. So this is fused, the gas passes and the moisture is absorbed by the drying agent. So this is what I explained you. Thanks for watching the video, and keep on just learning new things and new concepts. And I tell you one thing, that when I teach you something in depth, that's something I am enabling you to, or I'm enriching you with the concepts. If your concepts are clear, and when you come to solve the past year papers or the exercise of the chapter, it becomes very easy for you to think beyond the text, what's given in the textbook. So just keep on watching and keep on learning. I'm here to help you all the time, and I welcome your feedback and comments, through which I am improving myself every day. And I'm leaving you with the hope that this lecture was a really help for you. May God bless you. Khuda Hafiz.